Today we're going to talk about solving linear inequalities. And you saw linear inequality. Well, you saw inequalities first semester, and with less than, greater than, less than or equal to, and greater than or equal to signs. We want to start with this first problem. It says tell whether the ordered pair is a solution of the inequality. So you're given values for x and for y, and we want to plug them into our inequality. So we want to say is 4 less than 2 times negative 2 plus 1. And so 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. And is 4 less than negative 3? The answer is no. So no, that is definitely negative 2 comma 4 is not a solution of that system. Or of the inequality, I should say. So let's try the next one. We are given values for x and y. X is 3, y is 1, and we want to know is 1 greater than 3 minus 4? And 3 minus 4 is negative 1, and 1 is definitely greater than negative 1, so we are going to say yes, that 3 comma 1 is a solution of that inequality. Now we want to graph linear inequalities, and it's really similar to graphing lines, except we're just going to do some shading on our graph. What we want to do is solve the inequality for y. We're basically getting it into slope-intercept form, and we're going to graph the line. We call it the boundary line. If it is a greater than or equal to or a less than or equal to sign, we're going to use a solid line. And if it's just a less than or greater than sign, we're going to use a dashed line. We are going to shade the half plane above the line if it says y is greater than or y is greater than or equal to. And we're going to shade the half plane below the line for y is less than or y is less than or equal to the value. And we'd like to check our answers as well. So let's start with this first line. We want to graph the solutions of y is less than or equal to 2x minus 3. We know that our slope of this line, if we had it in the form y equals 2x minus 3, if we had an equal sign there, the slope would be equal to 2 over 1, and the y-intercept would be negative 3. So let's go ahead and graph the line. We start with a y-intercept of negative 3. We go up 2, right 1, up 2, right 1, up 2, right 1. And we continue that, and you can, of course, continue the pattern. And before we make our line, we have to determine if we want it to be dashed or solid. And since it's a less than or equal to, it's got that equal to sign underneath it, we're going to use a solid line. So let's go ahead and make a solid line. Goes through those points. And I'm going to put arrows on the end. And now, since this is a less than sign, okay, less than or equal to, but since it does have a less than in there, we want to shade below the line because that's where values will be less than the line. So below the line. Okay, you get the idea here. Now, the way we check this is just choose a point that's in the shaded area. It doesn't matter what it is. Let's say I choose this point right here. That is the point 3, 1. This is how you check. There's really an infinite number of points that you can choose to check, but it helps to just choose one or two and see if this works out. We want to check that and see if it does satisfy the inequality. So we have y is less than or equal to 2x minus 3. We're going to plug in 1 for y and 3 for x. So 1 is less than or equal to 2 times 3 minus 3. Is that true? It's 1 less than or equal to 6 minus 3. It certainly is, because that gives you the statement 1 is less than or equal to 3, which is true. So it does indeed check out. And if you want to check some other points, just choose them from the shaded area. Okay, so now let's go on to another problem. We have 5x plus 2y is greater than negative 8, and we need to get this into slope-intercept form, so we are going to solve for y before we do anything else. So we have 5x plus 2y is greater than negative 8, so subtract 5x from each side. We have 2y is greater than negative 5x minus 8. We want to divide everything by 2. So we have y is greater than negative 5 halves x minus 4. Our slope is negative 5 halves, and our y-intercept is negative 4. So let's go ahead and graph that line. So we start with the y-intercept of negative 4. 1, 2, 1, 2, 3, 4 is where we go down on the y-axis. And then we have to go down 5 and to the right 2. So 1, 2, 3, 4, 5, and to the right 2. Now you can also do just the opposite. You could go up 5 and to the left 2. So let's do that as well. We can go 1, 2, 3, 4, 5 up and to the left 2. 1, 2, 3, 4, 5 up to the left 2, and you can of course continue that. Now we look at our line in slope-intercept form, and it says y is greater than. There is no equal to sign involved, so this is definitely going to be a dashed line. So we need to choose a dashed, something we have for a dashed line, and I have this right here. So I'm going to go ahead, make this dashed line. Of course, you can continue this. Okay. And since in slope-intercept form it says y is greater than that, we are going to shade above that line because that's where values will be greater than negative 5 halves x minus 4. So we're going to shade above that area. Okay. In reality, it goes right up to the line but doesn't include the line. In the other case, the previous problem we did, solutions could be found right on the line as well. And in fact, you can even think of, in the previous case, the shaded part included the line. In this case, because it's just a greater than sign, the shaded part does not include the line. So again, to check for a solution, pick a point in the shaded area. Let's say I pick this particular point here. That looks to be the point 1, 1. And so let's just check 1, 1. We're going to plug those values in for 5x plus 2y is greater than negative 8. We'll put them in place of x and y. So we've got 5 times 1 plus 2 times 1. We want to know, is that greater than negative 8? We'll put a question mark. Well, 5 times 1 is 5. 2 times 1 is 2. And 5 plus 2 is 7. So 7 is definitely greater than negative 8, so it does check. Now, when you come to class, what we're going to do is do problem number 3 together, and also, well, actually, no, what we'll be doing is working in groups on that problem, and on the word problem, we'll also be working on that. So those will be the first 2 things we do when we come back to class. Thank you very much.